Now here is our last example, and then you will be set to try out the I think 11 questions yourself. Simplify this expression to a single trig function. So we are going to have two methods, but before I describe the method, let's write this out, and let's write this in terms of sine and cos again. So if I do this, I'll get cos of x minus, now cotan is equal to cos of x over sine of x all over cosecant is the reciprocal of sine, so we'll get 1 over the sine of x minus 1. Okay, so now this method is going to be taking advantage of once you got this step done and you're looking at it, you say, hey, in my numerator I have a denominator, only one denominator, and it's sine of x, and hey, look, in the bottom of this complex fraction again I have a denominator with this just sine of x. So I can clear the fractions by multiplying both the numerator and the denominator by sine of x. Okay, so I'm going to call my method here multiplying to clear the fractions. And if that doesn't make sense yet, hopefully it will. So I'm going to multiply the numerator here by the sine of x and the denominator by the sine of x. Okay, so this whole complicated piece here is going to get multiplied by the sine of x, and this whole denominator in our complex fraction is going to get multiplied by the sine of x. So what happens here? So when I multiply the numerator by the sine of x, it will multiply there, right? So I'll get sine of x times the cos of x, and maybe I'll write the cos first. Cos of x times sine x. Now what happens when it multiplies to this term here? Well, then my sine is going to get cancelled out. So it's cos of x divided by the sine of x times the sine of x. So we're going to cancel those signs out, and I will get the cos of x. So the whole purpose of this was so that now my numerator of this complex fraction is not fractional anymore. So we're going to get rid of that complex fraction nature of this whole business by doing this sine of x over sine of x. So looking at the denominator, I will multiply this out, and I will get, well, 1 over sine of x times the sine of x, that's going to be equal to 1 minus, so now when this multiplies out, I get minus the sine of x. Okay, so that's kind of neat. So we're coming along quite well here. And so now I'm looking at my numerator, and I see a cos that can be factored out. So let's try that. If I factor out my cos, oops, I can't spell, cos of x, I will get sine of x minus 1 over, hey, wait a minute, the sine x minus 1 and 1 minus sine of x. Okay, we've had that pattern before, so I just want to remind you how that works. So if I have like 1 minus 4, that's different than 4 minus 1. Order matters when you subtract, right? So 1 minus 4 is going to be equal to minus 3. 4 minus 1 is equal to positive 3. So how are they different? When you switch the order, it's the opposite. So in other words, if I switch the order, that's the same thing as the opposite of when I switch it. Okay, so I'm going to take this denominator here, this 1 minus sine of x, and I'm going to switch the order here and say that that's equal to, when you switch the order, it's the opposite of what it is. So if you look at each term by itself, this 1 is positive, right? Once this negative gets multiplied out, that would make that 1 positive, right? Inside the parentheses, sine of x is positive. When it gets multiplied by negative 1, it becomes negative. So why did I do that? Why did I make the denominator look more complicated instead of less complicated? It's because, and I'm reaching for that red, because I can say, hey, now I've got this sine of x minus 1 term, and I've got the sine of x minus 1 term over there. So what am I going to get? I'm going to get, I need to get a little bit lower in my page, I think, and then a little bit of space. Here we go. So now I have, okay, cos cos of x, all divided by, now negative with a red line stroked out, really when I cancel these things out, really what I mean is I'm getting 1, right? When I'm dividing sine of x minus 1 divided by sine of x minus 1, I get 1 both times. So this is cos of x divided by negative 1, which is going to be the same thing as just a negative cos of x. So there is my answer. Okay, so that is the first method. So, and that's a pretty cool way to look at this and say, hey, I can clear these fractions by multiplying the top and the bottom by the sine of x. But we do have another method. If I switch to green, maybe it'll be less. Oh, that was method 1. Okay, so this will be method number 2. Method number 2 is the good old workhorse of a method, which is convert everything to sine and cos, and then have common denominators. Okay, so it's a method that we've done before. So the first step is to, just like we did the first step before, is change this cotan into cos over sine and change that cosecant to 1 over sine. So really I'm just going to copy out the same first line. And now I'm going to say, okay, now in my numerator I want a common denominator, so I'll actually just add it here. We'll use some red here. So this is going to get turned into, I'm going to multiply the top and the bottom of this by the sine of x, so this will get a sine of x here times the sine of x. Okay, so this gets multiplied by sine x over sine of x. Likewise, over here this is going to get multiplied, this 1 will get multiplied by sine of x over sine of x, so I'll say, so my next line, my numerator will be sine x cos x minus the cos of x all over the sine of x divided by 1 minus the sine of x all over the sine of x. And I think maybe I should get some colored highlights just to see what was what here. Okay, so it's this part here is this, right? And since they both had sine of x, that's why they got combined together. And in my line below that, here, these two turned into this. Interesting how my red turned black over there. Okay, do you see how that works? Now we're going to do our favorite part, which is the multiply by the reciprocal. In fact, even at this point, you can, instead of multiplying by the reciprocal, you could do the old multiply by sine over sine. It's the same thing that we did before. Oh, I need to pause. Okay, so now it's time to do our multiply by the reciprocal business. So we are going to have here the sine x times the cos x minus cos x all over sine x, and I might be running out of room here again. See what happens if I move this over a little bit. Here, multiplied by, now, so it's the reciprocal of that other fraction, sine x all over 1 minus the sine of x. And again, I'm just going to put some brackets around here because this whole thing is being multiplied in this part here. So the first thing I see is, hey, I can scratch out these sine of x. They cancel each other out, which is kind of cool. And then it looks a lot like we had in our previous example, where I'm going to have the sine x times the cos of x minus cos of x all over 1 minus the sine of x. And now similarly, we're going to be factoring out a cos in the numerator. So I'll get sine of x minus 1 all over 1 minus the sine of x. And just to quickly simplify, this exactly the same line that we had before. So here I'm going to get is equal to times the negative cos of x. Alright, so I hope that's good. Now you'll see that we have those questions and we've got answers inside the front cover. So I hope you do well on it, and good luck. We'll see you soon.